Alright guys, in this video we're going to talk about the water displacement lab technique. So this is something that you're going to be doing very similar with your lab on Wednesday. So what we have set up here is basically you have a sample. So in this case it's KClO3 and that's a solid, and you're heating that solid up. And when you heat that solid up, it's going to produce a gas as one of the products. And so that gas is traveling through this tube and being collected by water displacement. Basically, at the very beginning, before you start your reaction, all of this container is filled up with water. And whenever the gas is being produced, it's going to displace that water, so we'll get a certain amount of gas that is produced there. When we're working with this, we can determine the pressure of the gas collected, so O2 would be our gas collected, by a simple technique here. And so basically, the pressure that you have at the gas, that's equal to your total pressure and or basically your total pressure that you have as you're reading here, this atmospheric pressure, that's equal to the pressure of the gas, but also the water that you have here has a vapor pressure as well. Vapor pressure is defined as the pressure at the surface of a liquid. And so it's basically how much pressure it takes in order to convert that liquid into a gas. So if I want to find the pressure of just the gas, when I take the reading here, that will be my total pressure. I have to subtract the pressure of the water that is present there. Now, where I'm figuring out this vapor pressure or the pressure of the water is basically I'll have a thermometer stuck into this water bath here, and according to the temperature of the water, I basically look up a constant to figure out what is the vapor pressure of water at that particular time. Most of the time in a free response question, it will be given to you as well as a multiple choice question. Sometimes they'll have like a little data table and you'll pick it out from the data table. So this is nothing you have to memorize. The vapor pressure of water changes as temperature changes. So that's why we have to know specifically what the temperature of water is and then look up that value from there. So again, in order to figure out the pressure of the gas that's in here, I take the total pressure, which is the reading of the pressure that I will get here. Most of the time, it will be the atmospheric pressure. And then I subtract the vapor pressure of the water. And again, this is a value that I look up. Once I know the pressure of the gas individually, then I can work with PivNerd, I can do stoichiometry, I can do all sorts of things from there. So we use this water displacement technique in order to collect a gas so you don't have to worry about gases escaping. So you're making sure you're collecting all of that. So I have an example problem here for us to work together. And what this example problem is saying, I'm going to have to switch over to my mouse. Here we go. So we have a sample of solid potassium chlorate, and it's heated in the test tube. And so our decomposition reaction we see here. So it's 2ClO3 goes to 2KCl. I'm supposed to say KClO3 plus 3O2. And so the oxygen produced was collected by displacement of water. So this is the lab technique we're talking about. This is what we'll be working with in our lab later on as well. Of water at 22 degrees Celsius at a total pressure of 754 torr. So this total pressure that you have here is the pressure of the gas plus the pressure of the water, or vapor pressure of the water. So in order to figure out the pressure of just that gas, we're going to have to take this total pressure and subtract the pressure of the water there. So it also tells me a volume of the gas, and we can figure that out if we have like a little graduated cylinder there. And it tells me the vapor pressure of water. Calculate the partial pressure if of O2, and we also want to figure out the mass of this KClO3 that was in the sample that decomposed. So there's two questions we're trying to ask here. First of all, for the partial pressure of O2, that's the pressure of the gas collected, we're going to take the total pressure and we're going to subtract the pressure of the water according to its temperature. So our total pressure was 754 torr, and our pressure of the water is 21 torr. So all I have to do is subtract those values, and when I do so, I end up getting 733 torr. So that is my pressure of the O2 by itself. Now, of course, when we're working with Pivnert and all those things, we're going to want to convert this to ATM. So let's go ahead and work with that. So 733 torr. To convert, we divide by 760, and that gives us ATM. And the value doing that calculation is 0.96 ATM. So this is the pressure of O2 that we have found there. Now for the second part of the question, let me move this up a little bit. The second part of the question wants us to figure out the mass of KClO3. So we're going to need to be able to look at my balanced equation for this because we're going to have to do a little bit of stoichiometry. So I have the pressure of O2. I have the volume of the gas, so I have the volume of O2, and I know my temperature, which is at 22 degrees Celsius. So what I can do here, since I have all of this information, I can use Pivnert, PV equals nRT, in order to solve for moles of O2. And if I know moles of O2 in this reaction, I can use a stoichiometric ratio to figure out moles of KClO3. Well then, if I know moles of KClO3, I then can figure out the grams by working my stitch there. So that's my approach. Again, how I know that is because I have information about one thing in my reaction and I want to convert it to something else in my reaction. So I'm going to get into moles, do mole-to-mole ratio, and then get out of moles into whatever I want to. So this is just a review of stoichiometry. So sticking with Pivnert, I know that my pressure is 0.96 ATM. My volume is 0.65 liters. N is what I'm solving for. R is 0.0821. T is my temperature converted to Celsius. So I have 222 plus 273. That's equal to 295 Kelvin. Now I'm going to solve for N. And again, N here is the moles of O2 because that's the gas that I've collected there. So I end up finding that I have 0.0258 moles of O2. Now my approach is just stoichiometry. I have moles of O2. To convert to moles of KClO3, I'm going to use my mole-to-mole ratio, which is a 3-to-2 ratio. So I have 3 moles of O2 for every 2 moles of KClO3. And now that I'm in moles of KClO3, I've gotten out of moles of O2, all I have to do is use that molar mass. So adding up the molar mass of KClO3, you end up getting 122.45 grams. So again, that's just added up on the periodic table. You divide by moles because 1 mole is equal to that mass. And now doing the math, so I take 0.0258 times 2 times 122.45 divided by 3, and that value gives you 2.11 grams. Let's label grams of what? That's KClO3. So this is my final answer there. So there's lots of different things that you could actually look for whenever you are working with this gas collection method of water displacement. In the lab that we're going to do in class, we're going to figure out the unknown metal that is being burned and things like that. So it's just showing you a little bit of variety. There's some free response questions that deal with this lab technique, and so you have that in your practice, and we're going to work some later on as it gets closer to exam time as well. So I hope this is helpful and hope it'll get you ready for your lab that you'll do soon.